Today we will be covering Lesson 32-1, the square root method. We will be splitting this lesson into 5 sections, questions 1 and 2, example A, question 3, question 4, and example B, along with question number 5 in that last section. Let's go ahead and take a look at our introduction for questions 1 and 2. It starts off by saying, Nguyen is trying to build a square deck around his new hot tub. To decide how large a deck he should build, he needs to determine the side length x of different sized decks given the possible areas of each deck. He knows that the area of a square is equal to the length of a side squared. Using this information, Nguyen writes the following equations to represent each of the decks he's considering. Number 1, solve each equation. Be prepared to discuss your solution methods with your classmates. X squared equals 49. Well, to find out the value of x, I want to know what number times itself will give you 49. So we could say the square root of 49, but please keep in mind that this could be x equals 7, or it could be x equals negative 7, because negative 7 times negative 7 is indeed 49. All right, x squared equals 100. What number times itself will give me 100? Positive 10 and negative 10. And I could do square root of 100. What it does is it gives me the principal square root, the positive, but there is a negative counterpart to that. So you might see it sometimes written as x equals plus or minus 10. This means positive 10 or negative 10. Okay, so that plus minus key means positive or negative. Here, this would be x equals positive square root of 15 or x equals negative square root of 15. There's not a perfect square root of 15, so I'm going to leave it as is here. 2x squared equals 18. So the first thing we would do is divide by 2 here. So that would give me x squared equals 9. And there is a perfect square here. Positive 3 and negative 3. Okay. Here we're going to solve for x squared, so we're going to add 4 to both sides. This is going to give me x squared equals 4. There is positive 2 and negative 2. So I'm going to do the plus minus 2 here. All right, here we would subtract 2 from both sides. So x squared equals negative 2. There's an issue here. Watch this. The square root of negative 2. See how it says non-real answer? We can't take a number, multiply it by itself, and get a negative. So this would have no solution in our case. Here, We're going to subtract 3 from both sides. X squared equals 0. So my answer here is x equals 0. I'm not going to put a positive or negative here because it doesn't matter. 0 doesn't contain a positive negative. It's just 0. Number 2, refer to the equations in item 2 and their solutions. What do the equations have in common? All of them have that x squared term to them, so they are all quadratics. Okay. What types of numbers are represented by the solutions of these equations? All of them have real answers except for 1f. How many solutions do the equations have? All of them have 2 solutions except for 1f and 1g. Recall that 1f has no solutions, and recall 1g only has 1 solution, x equals 0. Now, reason quantitatively. Which solutions are reasonable for the side lengths of the square, and explain? So remember that each one of these had a positive and a negative answer. But if we're talking about a square, is it possible to have some of these answers as side lengths? Only the positive solutions are reasonable. A length cannot be negative or 0. If you have a length of 0, that means that the side doesn't even actually exist. That doesn't make sense. All right. Go ahead and copy down 1 and 2. There's a debriefing on the next slide. Go ahead and get that answered, and then we'll move on to the next set of questions.